Alright guys, so this is section 2 with combining like terms. So I'm going to tell you that there's some vocabulary that we need to get into and make sure that you understand. And also just to let you know that this section some people start to trip up a little bit, and that's because you got a lot of things coming all together all at once and combining like terms. You have knowing your properties, you have integers coming into play, you have this new vocabulary, and all this stuff is coming together in one place. So some people they struggle a little, so give yourself time. It takes a little practice, but you'll get it and you'll be super awesome at it. Okay, so let's talk about these terms. So first we have this word term. So in math, a term is each piece of your expression. So for instance, if we give you a little example here, so if you want to write that down, make sure you write that down real quick. Each piece of your expression, and you know that you've gone from one term to another when you hit an operating sign. So let's look at like 3x plus 6 minus 2 plus a 7x minus x, and let's stop there for right now. All right, so each piece of this is a term. Okay, so let me change colors here. So 3x, that's a term. 6 is a term. Notice I'm circling the operating sign with it. That is because, and this is one of those tricky things that makes this section a little hard, you have to remember that an operating sign travels with the guy behind him. They're like, I don't know, they're codependent. They can't operate without each other. So the operating sign travels with the guy behind him. So this we treat as if we're subtracting 2 or sometimes a -2, okay? And then that's a little hard for people to start like flexing their mind, like sometimes I'm going to treat it like, when do I treat it like a -2? Well, that's like if it's the first number that we're combining, when we combine in a minute, you want to treat it like a negative. But then when it's in between, you're going to treat it like a subtraction, okay? So then this right here is a term, and this is a term, okay? That minus x, and you're going to pretend like there's a 1 there, right? Because we don't write it, because that would be redundant if you do like 1x, because if I just see an x there, I know I only have 1. If I had 2, there'd be a 2 there. All right, so term, one more time. Each piece of your expression separated by an operating sign. So that's how I know I go from one term to the next, is when I hit an operating sign, I'm at my next term. Okay? Then we have this thing called like terms. Those are each piece that can be combined together. Okay? So if they don't have a variable, all those things get added together, and we're going to learn what that's called. Actually, let's just talk about it right now. Let's not hold off. So each thing, or each term that doesn't have a variable with it, so that'd be this -2 and this 6, these guys are called down here constants. So they're a number without, and this is shorthand, with/out is a shorthand for without, number without a variable. Okay? So that's what a constant term is. So it's each piece that doesn't have a variable. All right, now, then you have the ones that have variables. The variables have to match. So if there's more than one, like if we had, here we just have x's, but if we had x and y, then the x's are all the same, all the terms that have an x in it. But the other ones that have an x and a y in it, those are different, okay? So like terms are each piece that is the same kind of term. So if it has a variable, it has to have the same variable raised to the same power. Okay? And all the constants go together. The constants are always all like terms. Okay? So like terms. So in this example here, our like terms are going to be the 3x, the 7x, and minus 1x. And then because of our properties, this is why section 1 was a review of those properties, because they come into play here. Because of the commutative property, I can shuffle things around that I want to combine together. So 3x plus a 7x minus an x. I can go ahead, all those are like terms, so I can go ahead and in my mind, I put them all together. But on paper, if I was like writing out all my steps, I'd shuffle these all next to each other. That's the commutative property. So 3x plus 7x minus an x is going to be 9x's. Okay, and then my 6 minus 2, that's going to be 4. Okay, so like terms are all the pieces I can combine together. And then on this line, let's look at this. 3x and a 7x are like terms. Okay, now a 8 and a minus 4, like terms, because these are constants. Okay, and then if I had like a 4xy and an 8xy, those are the same. Okay, what's not the same is 4xy and a 7x. Same exact variables raised to the same exact power. Well, this doesn't have a y, because if you think about what this means 7 times whatever x's value would be. This would be 4 times x times y. That's different because that y. Okay, also what would be different? These would not be like terms. These would not be like terms. 3x and 7x squared. These are not like terms. Not the same. It has to be the same variable raised to the same power. This is technically a 1 here. Okay, so it's x to the first power. This is x squared because this means 3 times x. Done. This means 7 times x times x. That's different. Okay. Also, what would be different? These guys right now are like terms, but if I make either one of these squared or cubed or anything like that, these are now different. These cannot be combined together. So 4x y squared is different than 8xy, because this means 4 times x times y times y. This means 8 times x times y. Different. Okay. So like terms have to, if they have variables in them, it has to be the same variable raised to the exact same power. And then constants are always all combined together into one. Okay. Now the next term, we're going to get into this as we move through this. But each time you combine your like terms, you have an equivalent variable expression. So like if we actually do this guy here, okay, and we actually combine like terms, and let me change colors one more time. So if we combine like terms, 3x, and we said a 7x, that's 10 minus 1 is going to be 9. So this 9x, okay, now we combine these two guys, 6 minus 2 is 4. This is an equivalent variable expression to this, okay, because all I've done is I've simplified this, and I've taken 1, 2, 3, 4, 5 terms and made it 2 terms. And the reason we do this is because what if I want to graph something and it has x in it, or I want to do something, I want to figure out like x with different values. Well, do you want to pop in like first I have to try x as a 2, and then I have to try it as a 4, and then I have to try it as a 6.7. Do you want to put x into 3 different spots and figure all this out? Or do you want to stick it in one time, subtract 4? So I stick in the 2, subtract 4. Multiply by 4, then subtract 4. Put in my 6.6 times 9, subtract 4. That's much easier. So that's why we simplify it. So we want to bring it to your attention that these are equivalent expressions, these guys right here. So this guy here and this guy. This is your long extended version. This is the simplified version. Simplify means to make more simple, right? All right, so there's one more term here we haven't talked about, and that is coefficient. So what is a coefficient? So stuff without a variable, so like this 4, that's a constant, this minus 4 here, okay? Because he has no variable piece. Constant because he doesn't change. If I have a variable, like this number will keep changing on me. This term, it'll keep changing. Because if x in one situation is a 2, and then all of a sudden it's an 8, and then it's a 2.7, and then it's a 5. So this piece keeps changing, but this piece, we just keep subtracting 4 when we get to this step, right? Just keep subtracting 4, keep subtracting 4. So this part changes. So that's why this is called a variable, because an x in this problem could be a 2, the next time it could be a 7, you know. Okay, and this guy's a constant because he doesn't have a variable piece. So this guy right here, that's your coefficient. Coefficient, if you break down that word, coefficient, co means that I'm working together with somebody. Like if I'm co-captain of, I don't know, the football team, then it's me and the other person working together to get the duties of a captain done. Like we're working together to make sure all the stuff that needs to be done is done. Whereas if I'm just captain, it's all on me. Okay, so it means working together. So a coefficient is going to be the number that's with a variable. So like 3x, the 3 is the coefficient. 4y, 4 is the coefficient. 6xy, 6 is the coefficient. Minus 8x squared, minus 8, negative 8, is your coefficient. Okay? They can also be fractions. So you can have like 1/2 z. Oh, I got a little crazy there. Well, okay, so 1/2 z. Okay? The number that's with the variable is your constant. So like back at this example, coefficient. 3, coefficient. 7, coefficient. Minus 1 is our coefficient here. This is very important. Okay? So your coefficient is your number that's with the variable. Okay? So I have a little exit slip question where I'm going to have you name some terms and stuff. And then there's another video that's after this one, and that's gonna be when we actually start adding all and combining terms. Okay? So do the exit slip below, then watch the next little video and answer its exit slip. Okay? So I'll talk to you guys in just a minute as soon as you're done with your exit slip. Bye guys.